Welcome everyone to our statistics series on group data, SSCE aspect of it. Today we continue with our measure of spread, which is measure of variation and dispersion. We are taking mean deviation first for frequency distribution. If x1 on and on up to sk occur with frequency f1, f2 on and on up to fk, then the mean deviation is given by mean deviation, which is our MD, is equals to summation f, that is sigma f, absolute value of x minus x bar divided by summation f, where s bar is the mean. Let's take an example. The table shows the distribution of outcomes when a die is thrown 50 times. Calculate the mean deviation. Solution. Mean deviation is equals to sigma f, which is summation f, an absolute value of x minus s bar divided by summation f, where x bar is the mean. In this case, first we find our mean, and mean, which is s bar, is equals to summation f of x all over summation f, which is equals to 1 times 2 plus 2 times 5 plus 3 times 13 plus 4 times 11 plus 5 times 9 plus 6 times 10 divided by 50, which is equals to 200 over 50. The result is 4. Next, we prepare our table for the mean deviation. Now, our table for mean deviation shows the x value that originally given in the question, which is the scores, and the frequency. So the next item we are looking for is the x minus x bar. As we are subtracting mean, our mean value, which is 4, from each of the given x. And in the first case, we have 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. Then 4 minus 4 is equals to 0. Then next we have 5 minus 4 is equals to 1. Then 6 minus 4 is equals to 2. Taking the absolute value, which is the next column, anywhere we see minus, we're going to put it plus. That's just absolute value for you. So we now have 3, 2, 1, 0, 1, 2. Next, the next column is the frequency table, which is from the original equation. But after that, we have our f into f multiplying the absolute value, which we have gotten. So we are having a situation where you have 3 times 2, and that is 6. 2 times 5, 10. 1 times 13, 13. 0 times 11 is 0. Then we have 1 times 9, 9. 2 times 10 is 20. Summing our f into absolute value of x minus s bar, summation f there, will give you equals to 58. We're adding this last column. From our formula, mean deviation is equals to summation of x minus s bar, the absolute value, divided by summation of frequency, and that is 58 over 50, which is equals to 1.16. Next, the variance of a set of numbers x1, x2, into dot 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 up to sk is given as v equals to summation into bracket open x minus s bar bracket close square all over n, where v is the variance and x minus x bar bracket open square is the square of the deviation from the mean. Standard deviation is the square root of variance, which is the same thing as SD equals to square root of the formula we quoted for variance. Variance and standard deviation for frequency distribution. If the numbers x1, s2, on and on up to sk occurs with frequency f1, f2, on and on up to fk respectively, then variance v will be equals to summation of f into bracket open x minus s bar bracket close square divided by summation of f, and standard deviation sd is equals to the square root of the quoted variance above. Let's take some example to buttress the formulas. Example 1. Find the variance and standard deviation of the set of numbers 2, 5, 6, 3, and 4. Solution. Variance is equals to summation into bracket open s minus s bar bracket close square divided by n. But mean is equals to summation x over n. In this case, is equals to 2 plus 5 plus 6 plus 3 plus 4 divided by 5, which is equals to 20 over 5, and that is equals to 4. Next, we prepare our variance table. In the table, we have our given value, which are the x value 2, 5, 6, 3, 4. The next column, which is x minus s bar, which is we are subtracting mean from the given value. We have 2 minus 4 will give you minus 2. 5 minus 4 will give you 1. 6 minus 4 will give you 2. 3 minus 4 will give you minus 1. 4 minus 4 will give you 0. Next is the square of our subtracted value. And you know, any number squared, even if it is minus, become plus. So minus 2 square is plus 4. 1 square is 1. 2 square is 4. Minus 1 square is 1. 0 square is 0. Next, we sum out the value in this column, which is summation of x minus s bar square. And that will give us 10. Our working variance, which is equals to the summation of x minus s bar, bracket open and close, square, divided by n, is equals to 10 over 5, which is equals to 2. From here, our standard deviation is the square root of variance, which is equals to square root of 2, and that is the same as 1.4. Another example. Calculate the variance and standard deviation of the frequency distribution below. Solution. Variance is equals to summation f, to bracket open, x minus s bar, bracket close, square, divided by summation f. Whereas mean is equals to summation f of x all over summation f, which is equals to 2 times 1 plus 1 times 2 plus 2 times 3 plus 1 times 4 plus 2 times 5 all over 2 plus 1 plus 2 plus 1 plus 2, which is equals to 24 over 8, and that is equals to 3. Next, we prepare a table for the variance. In our variance table, x values were given originally along with our frequency. So we'll be looking for other items in the formula. First is x minus x bar, which is subtracting the mean from the x values. Our x bar is 3. So 1 minus 3 is minus 2. 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Next, we square the values. And as you all know, in mathematics, anything squared, whether it's minus or plus, the value becomes positive. So this time around, minus 2 square is plus 4. Minus 1 square is plus 1. 0 square is 0. 1 square is 1. 2 square is 4. The next column is the column after the frequency table, which is f frequency multiplying the value we got when we square the differentials. And in this case, we have 4 times 2 will give you 8. 1 times 1 will give you 1. 0 times 2 will give you 0. 1 times 1 will give you 1. 4 times 2 will give you 8. The summation of what we have gotten in this column will be equals to 18. Next, our variance will be equals to 18 over 8, which is equals to 2.25. And standard deviation is equals to the square root of variance, which is equals to square root of 2.25, which is equals to 1.5. Let's take another example. The variance of a given distribution is 25. What is the standard deviation? The options are given. Solution. Standard deviation is the square root of variance. In this case, SD is equals to square root of a variance, which is equals to square root of 25, which is equals to 5. Another example. The table shows the score obtained when a fair die was thrown a number of times. If the probability of obtaining a 3 is 0.26, calculate the standard deviation of the distribution. Solution. First, we find x by the principle of probability, which is probability of 3 will be equals to frequency of 3 all over the summation of the frequency. In this case, we have 0.26 is equals to x all over the summation of the frequencies, which is 2 plus 5 plus x plus 11 plus 9 plus 10. 0.26 will be equals to x over 37 plus x. When we cross multiply, we have 0.26 into bracket open, 37 plus x, bracket close, is equals to x. When we open up the bracket, we have 9.62 plus 0.26x will be equals to x. From there, we collect items together. We have 9.62 will be equals to 1x minus 0.26x. Conveniently, it becomes 9.62 will be equals to 0.74x. From here, we know that x is equals to 9.62 divided by 0.74, which is equals to 13. Having gotten the value of x, we can now work for our standard deviation. Standard deviation is frequency distribution. It's equals to summation, the square root of the summation f, bracket open, x minus s bar, bracket close, square, all over summation f. From here, our mean x bar, which is equals to summation f of x over summation f, will be equals to 1 times 2 plus 2 times 5 plus 3 times 13 plus 4 times 11 plus 5 times 9 plus 6 times 10 all over 2 plus 5 plus 13 plus 11 plus 9 plus 10, which is equals to 200 over 50. And that is the same thing as 4. Next, we prepare our table for standard deviation. I've only set the items of the formula for standard deviation on the table. We start with x minus s bar, and that is, we are subtracting the mean from the s value. So 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 is 0. 5 minus 4 is 1. 6 minus 4 is 2. Then squaring the value gotten, which is the next column. Minus 3 square is 9. Minus 2 square is 4. Minus 1 square is 1. 0 square is 0. 1 square is 1. 2 square is 4. Please take note, anytime you square a minus value, it becomes positive. Next column is after the frequency. So we are multiplying frequency times the value we got in the column of x minus x bar square. And that would be 9 times 2, 18. 4 times 5, 20. 1 times 13, 13. 0 times 11 is 0. 1 times 9 is 9. 4 times 10 is 40. We sum the value gotten in this column, which is equals to 100. Thus, our standard deviation, substitute our given formula, will be equals to square root of 100 over 50, which is equals to square root of 2, and that is equals to 1.4. We've come to the end of the examples under the topic we treated. Next, we have some exercises that are taken from page 123, the hidden fact in SSCE mathematics. Please try your hands on the exercises. The answers are given at the answer section of the book, either the hard copy or the soft copy. Thank you.